Autophagy, the body's remarkable system for cellular housekeeping, plays a critical role in maintaining health and longevity by clearing damaged proteins, dysfunctional organelles, and other cellular debris. It functions as a cellular recycling mechanism, promoting rejuvenation and protecting against age-related diseases, metabolic disorders, and even some cancers. While fasting and certain stressors are known to enhance autophagy, dietary patterns, particularly those related to carbohydrate intake, can either support or inhibit this vital process in profound ways. Understanding how carbohydrate-related nutrition interacts with autophagy reveals not only the vulnerabilities of high-carb diets, but also the opportunities to use carbohydrates more wisely to support metabolic balance and cellular renewal. High-carbohydrate diets, especially those dominated by rapidly absorbed, high-glycemic carbohydrates such as white bread, sugary snacks, and sweetened beverages, tend to suppress autophagy primarily through their effects on insulin and the mTOR pathway. When we consume these kinds of carbs, blood glucose levels rise sharply, prompting the pancreas to release insulin, a hormone that facilitates glucose uptake but also signals the body that plenty of energy is available. This flood of insulin directly inhibits autophagy as the body prioritizes building and storage over breakdown and repair. Simultaneously, insulin activates mTOR, mechanistic target of rapamycin, a central regulator of cellular growth. When mTOR is highly active, it further suppresses autophagy, tipping the metabolic scale toward accumulation rather than regeneration. In essence, the cell is told to grow, not to clean up. Yet, this story isn't only about avoidance, it's also about possibility. The relationship between carbohydrates and autophagy isn't inherently negative, it's conditional. The key lies in carbohydrate quality, timing, and context. Whole food sources of carbohydrates such as lentils, oats, berries, and sweet potatoes digest more slowly, produce a gentler insulin response, and can be harmoniously integrated into a lifestyle that supports autophagy. These foods often contain polyphenol, fiber, and resistant starch, which modulate postprandial glucose levels and improve insulin sensitivity over time. Improved insulin sensitivity allows the body to cycle more fluidly between feeding and fasting states, increasing the potential for autophagy to activate during periods of lower nutrient intake or physical stress, such as during exercise or sleep. Moreover, strategically incorporating carbohydrates in a cyclical or time-restricted eating pattern can help regulate mTOR and insulin in a way that still permits autophagy to function. For example, time-restricted eating, where meals are consumed within an 8 to 10-hour window, creates daily fasting intervals that allow insulin to drop and mTOR activity to subside. This gentle rhythm of feeding and fasting mimics the ancient metabolic patterns our bodies evolved to handle and can restore autophagic activity even in individuals who do not follow a strict low-carb or ketogenic diet. In this context, carbohydrates serve more as tools than obstacles, allowing us to energize the body during active phases and support repair during rest. Additionally, there's a growing understanding of how certain carbohydrate-rich foods may actually enhance autophagy indirectly. Fermented grains and legumes, for instance, contain bioactive compounds that influence gut microbiota and may modulate autophagy through short-chain fatty acid, SCFA, production. SCFAs like butyrate, produced when gut bacteria ferment dietary fiber, have been shown to upregulate autophagy and protect against oxidative stress. Thus, the conversation around carbohydrates and autophagy need not revolve solely around suppression. It can also include enhancement, provided we choose the right forms, in the right quantities, at the right times. In this light, carbohydrates become a nuanced player in the autophagy landscape. Rather than being universally detrimental, they are context-dependent regulators. Processed, high-glycemic carbohydrates consumed frequently and without restraint disrupt the metabolic environment required for autophagy. But whole, fibrous, and nutrient-dense carbohydrate sources, particularly when consumed within metabolic-friendly eating windows, can actually coexist with and even promote autophagic cycles. It becomes less about vilifying macronutrients and more about understanding the cellular language they speak. Ultimately, balancing autophagy with carbohydrate intake is about more than nutrient ratios. It's about rhythm, intention, and metabolic intelligence. By tuning into how carbohydrates affect our internal signaling pathways and making mindful adjustments, we can support the body's natural ability to renew itself. The goal isn't merely to restrict carbs, but to align carbohydrate consumption with the cycles of energy use and cellular repair that our biology craves. In this way, We can enjoy the energy, comfort, and satisfaction that carbohydrates provide, while still empowering the profound self-cleaning process that is autophagy.